Hello, my name is Luke Haskell. This is my assignment 5 submission, buffer overflow for CS 4770. So let's get into it. I got the provided C file all loaded up here. I'm going to run the debug, the VS Code debugging feature thing. I've put a breakpoint here in the F function. And so the point of this assignment was to access the TBD function, which normally is never accessed in the normal running of this file, by overriding the return call at the end of the F function to, instead of going back to main, it goes and calls TBD and prints out whatever this means. I'm sure it'd be clever or funny if I knew what it was from, but alas. Okay. So what I discovered, at least on my machine, is that from the beginning of the buffer address, which is that DAA, with a bunch of F's and a 7, but I'm only going to be referring to like the last 4 bytes of that from here on. So from that to 14 bytes later, which you can view by doing this. It's a little screwy in the VS Code. 5, 3, 4, 5, 6, 7, DAA. And that is what's in buffer right now, which is nothing, because I haven't ran the line yet. The 14 bytes later is B8. You can see right now, that is the call return address for main. We can view that by doing main, TBD, it'll show the address. This isn't exactly matching up with main. I think that's because it doesn't go to the first spot of main. It's got to continue like down here, if I were to guess. Either way, trust me, it does work. C is not, in fact, a broken language. So we want to get it to 401176, which is the call address of TBD. So, like I said, this is 14 bytes exactly from the beginning of buffer. So I pass in the command line argument this string. So the first 6 letters are just lowercase r's. Well, the first 14 don't matter. It was just so I could keep track of when I was stepping through memory. The first 6 r's go into the buffer, and then the next 8 c's are just fill the white space. They might overwrite something. They might not. I don't really care. All we're trying to do is to get 14 bytes ahead of the code from the beginning of buffer to print this out. And this is a representation of 401176 in ASCII characters. It kind of goes backwards. So the @ symbol is 40 hex in ASCII. Hex 11, the first 32 characters of ASCII are like not really typable. So it took me longer than I'd like to admit to figure out that I could just do this. But this is how you would do non-printable. You could do this for every character, but I thought it was more cool to overwrite stuff with an @ symbol and a V. But this is ASCII character hex 11. So we got 40, 11, and the last thing we need is 70 or 76, which happens to just be lowercase v. So we pass that in, which starts right at the 14th byte away. And if we step through the code here, I'll just step through once, and then you can see that the buffer gets filled. I'm not going to step through all the memory, but then we'll skip. So that's the buffer, 4 bytes of the buffer. Then we can now see the DAB8, DAB8 is now 401176 instead of 40123B, because we overread it with those 3 special characters. But it's not, the characters aren't special in themselves, they just happen to be the numbers we needed to overwrite this. So now if we step through this, it does a normal, but when it reaches the end of the F function, it goes to TBD. Wow, look at that. It prints this and gets to the end, and then it crashes or whatever because it doesn't expect it to do that. But important thing is that we successfully completed a buffer overflow attack using some simple memory counting and a little bit of clever character picking to overwrite specific numbers in a specific place in the memory address. So, yep, this was a lot of fun. I really enjoyed this, figuring it out, and it's kind of all the steps of it was very interesting. So yes, thank you for watching.